It may be helpful to review the identifying acids and bases and acid-base reaction videos before you watch this video. Remember that a acid is defined as something that produces H3O plus in solution. And a base is something that produces OH minus in aqueous solution. When we're working with acids and bases, we're often concerned with the amount of H3O plus hydronium ion there is in solution and the amount of OH minus in solution. These concentrations can range anywhere from 10 to the minus 13 or 14 molar to 10 or more molar. And so there is a really wide range of concentrations that we can have for the hydronium and the hydroxide ions in solution. When we have a really wide-ranging variable, a variable with a wide range of values, we often report that variable in terms of a log scale. So we're going to use a log scale to report the concentrations of hydronium and hydroxide ions in our acid and base solutions. So what you'll notice is that the majority of this scale is down here at concentrations that have a negative exponent. And remember that when we have a log scale, the log of a number reports that exponent, that power of 10 that defines the number that we're interested in. So for instance, the log of 10 to the minus 13 is equal to minus 13. It's just equal to that exponent on the 10. But we don't really want to report our values in terms of negative numbers, and so what we're going to do is we're going to multiply through by a minus sign and make this positive. And so we're going to define the pH of a solution as minus the log of the H3O plus concentration. And the pOH will be defined as minus the log of the OH minus hydroxide concentration in solution. Notice that I am basically using this symbol P to mean minus log. And so I can sort of think about this P as meaning minus log. And so anytime we have something that is P something, some variable, we mean minus the log of that variable. So for instance, I sometimes talk about pKa, which is minus the log of the acid ionization constant, equilibrium constant for a particular acid ionization. Or I might talk about pKb, and that is simply minus the log of the base hydrolysis equilibrium constant for a particular base in solution. So these are the definitions for pH and pOH. Notice that on the P scale, on the log scale, these concentrations run from a pH of 13 to a pH of minus 1, because the log of 10 is 1, and so log of 10 is 1, so minus the log of 10 is minus 1. So when we have a very low concentration, we're going to have a larger p-value. When we have a very high concentration, we're going to have a smaller p-value. And so things work in a sort of reverse direction because of this minus sign. So what you need to remember is that larger p-values is a smaller concentration.